In this video we've moved on to scientific notation, and I'm going to split that into two parts. That's just writing numbers in scientific notation and from scientific notation back to standard form, and then we're going to look in a separate video at operations with numbers in scientific notation. Okay, so moving along here, remember when we write numbers in scientific notation, the first part of the number has to be a number between 1 and 9.99999. So in this case, using the digits 6, 8 and 5, we can get 6.85 times 10 to the. Now at the moment the decimal point's here, and we've moved it along until it gets to there. So to count those places, it's moved 3, 6, 9 places, so that's 10 to the 9. That's one way to do it. Or we could think of this as being 6.85 times a billion, which is 10 to the 9. So, okay, the second one, we've now got a number that's much more than 1, much more than 1. So we know that the power of 10 this time is going to be negative. The decimal point simply has moved in the opposite direction. But given the digits that we have in this particular number, 7.85 is our number that we can derive that's between 1 and 10. And this time the decimal point had to move 3, 6, 7 places to get to where it is in this front part. So it's going to be 10 to the negative 7. And the last one here, 1.25. Well, we know that's got to be 1.25 because that's the only number between 1 and 9.9999 that we can get from that, times by 10 to the something, but it's got to be 10 to the 0. Anything to the power of 0 is 1. So basically these two are the same because this turns out to be 1.25 times 1, which is 1.25. Okay, moving on to the next slide. We have numbers that are written in scientific notation, and we've been asked to put them back into standard form, or what you might call ordinary numbers. So the first thing that I do with these is I have a look at the power of 10 to see whether I'm dealing with an extremely big number or an extremely small number. And we know this first one's a big number. So I'm going to write 4.95, and I'm going to put a few zeros, quite a few zeros on, and then I'm going to move that decimal point 7 places to generate a big number. So 1, 2, 3, 4, 5, 6, 7. So I might just rub these out. I have the luxury of being able to do that. And then I want to count in groups of 3. There's a group of 3, a group of 3. So this is 49,500,000. Okay, we can double check that too, because if we go backwards to scientific notation, we've got to get 4.95, and the decimal point would have to move 3, 6, 7 places to get to be 4.95. The second one I'll do down here. Once again, I'm going to put 9.2, and because it's a small number, and we know that because it's 10 to the negative 4, I'm going to put my zeros in front this time, and I know I've got to move the decimal point 4 places. So 1, 2, 3, 4. So that's 0 point and 1, 2, 3 zeros, and then 9, 2. So working backwards, if I was to put this number into scientific notation, the decimal point would move 1, 2, 3, 4 places. It would be negative because it's a small number. Okay, the third question here, 10 to the power of 0 is equal to 1, so this is just 1.79.